Cool. So hey everyone. Yeah, first of all, sorry for the noise outside. There is some construction going on, but yeah, we have to roll with this. So hi, my name is Abhas. I currently work as a UI engineer at Flipkart, and what I wanted to talk about is how completion records work in JavaScript. So completion record is something that you have normally not heard of, but this is how all the data flows within JavaScript according to the specification. So let's say whenever you use like break, continue, return, or even if you just do 2 plus 3, right? That data or data value has to move from one function to another, right? So this is how it is works. So for example, so this is two things that you normally know, that we have expressions and statement, right? So if you use 2 plus 3, that will give you 5, right? Now if you pass 2 plus 3 into a function, that function will get that input has 5, right? So somehow this value that you produce here is flowing to other parts, right? Now similarly, we normally don't think of statements as returning something, right? So for example, if you see this, we know that okay, if you run a if else statement, if you do this, right, basically nothing is happening. You can't really assign this value 10 to something, right? You cannot do a equal to this value, because you cannot put something before any statement, right? But internally, or both of these things, right, both expressions and statements return something. Now just to continue, these are the other things which we know changes how our code works, right? So you have break and continue. So normally we use break and continue in some kind of a edge case, or in some cases to stop some loop, right? So you'd have, if you have some kind of a recursive algorithm, or if you have like a for loop that runs infinitely, you do something like that: if I is 0, then break out of the loop, right? So these are normally considered as something which you will use when you have that edge case, or when you reach that terminal condition, right? And then we have return statements. So return is what you would use, let's say within a function, to basically return some value out of that function, right? So this is considered more or less as something normal, something that you use all the time, right? And then there is throw. So throw is usually used to throw some kind of a error, right? So it might happen intrinsically, like let's say you try to call some some variable or some method which is not a function, right? So you do a dot b and try to call it, but let's say a dot b doesn't exist. So in that case, JavaScript throws some error, or else you can also throw your custom values or your custom errors using throw, right? So if you think of it, normally when you're using these things, they all seem quite different, right? If you want to break out of a loop, or if you want to change how the loop works, you'll use break and continue. uh, and if you use return, that's more or less a normal value, right? Just some way of getting things out of a function. And then you have throw, which you'll usually use if some unexpected situation occurs, right? So mentally all of these sound quite different, but how it internally works is that all of this works through a common way, right? A common method called completion records. So what does that mean, right? I said that okay, everything returns something. That is the point. Not in sense of JavaScript return, but if you think of how this would be working within a JavaScript engine, everything returns something. So let's say we move to the next one, right? So let's say you have this, you have 2 plus 3, that is expected, it will return 5, right? But if you have a if else, something like this, if false, if it is true, then it will return 10, if else it will return 20, right? So normally we think the statements don't really return something, but if you put that within a eval, right, you'll see what is the return value of this whole statement. So let me show you that, right? So let's say we do the same thing. Normally if I write something like this, we have to use the statement, okay. uh, So yeah, so if you look at the JavaScript console, right? So normally we think that okay, it's a statement. So if it doesn't return anything, but if you see here, it prints this value 20, right? And this will of course change if you change the condition of if statement, right? So it seems like our statements do return something, right? Um, and of course, if you run some kind of expression, that will also return the value. So both of these actually internally return something called a completion record. So we'll go to that. Um, okay. So what is a completion record, right? Before that, let's talk a little bit about the specification, right? So let me actually open that. So let's say just like a short intro to what is the ECMAScript specification. That we all use JavaScript, right? And JavaScript has so many engines. So you'll use it in Node or V8. You'll use it in multiple browsers, right? So you'll have like Chrome, Firefox, Opera, all of that, and basically all of them is implementing some JavaScript engine. Now there has to be a common, a common way of defining how JavaScript works, right? Or else it might lead to edge cases. So for example, let's say you have two engines, JavaScript engines, right? And let's say if you pass an empty array to if, right? Let's say if I do this, so if I do this, right, if and I pass an empty array, so now someone has to decide whether empty array turns to a truthy value or it turns to a falsy value, right? Now if you had multiple JavaScript engines with no common definition, then one might implement it as true, one might implement it as false, right? So you can have these differences, which would make it very hard for JavaScript developers to write any kind of code, right? Your code will not work in the exact same way in all the engines. So that's why what we have is a common definition of the language JavaScript, right? So this ECMAScript language specification, right, is like a HTML document. So what this basically does is that it ensures that it talks about like how everything in JavaScript works with a lot of details, right? The point being that whoever is now implementing a JavaScript engine should should stick to the definition, right? They should effectively return the same things. They should effectively have the same effects, right? So that is what this ECMAScript language specification, or in a simple way, the JavaScript specification is like. So now this is basically a HTML document, right? Just a HTML page. It's not written in any kind of code. So basically, if we go back here, right? So it defines how all of the parts of JavaScript work. So let's say if you have if statement, right? So this is talking about how that will look. So the first thing in about anything, right? So it says that if statement, and it says that there is like two forms of if statement. So if statement can look one of these two ways. Okay, so that is what this means. Now these syntaxes that you see, these are typically called as BNF grammar in like computer science lingo, right? So what is basically saying is that like these are the two syntaxes of if statement. If you ignore these parts, just ignore these sections, right? What it's basically saying is that if should look like this. I have a if starting bracket, some kind of expression in between, then I close it, and then I can have a statement here, right? And then again else, and then another statement. So this is the form where you have both if and else, and this is the other form where it says that you can also have a if statement where you just have an expression and just first statement, right? The else part is effectively optional. So if I again go back to code, right, what this is basically saying is that I can write a if statement like this. Let's say this is my expression in between, and then I can write any kind of a statement, right? So let's say I do console log hello. Now this is the basic form of a statement, right? So you can write only one line here, that is a statement. But normally when we write if else, we use the other form of statements, right? We start a curly brace like this, and then we write multiple statements in here. So how does that work, right? The specification has to tell you that this is allowed, right? So how does that work? So if we go back, you see that it says that, okay, if expression then a statement. Now this statement is again linked here, and it will again be defined recursively, right? So if I go to what is a statement, it tells me that a statement can be one of these many things, right? So what you used initially, let's say console log, that will be something like a expression statement like this. uh, but the other one, right, where you start a curly brace and then write multiple statements, that is called as a block statement. So if you go to a block statement, this is what it says, right? You have to literally start with a curly brace, and then you can have like a array of statements, like multiple statements, and then you have to close the curly brace, right? So this is how it is defined, that in the body of your if statement, you can either write a single line, or you can start a block and write like multiple lines here. So this is what the specification is telling us. Okay, so let's say, and the next thing would be that how is this thing running, right? If you write a if statement, how are you able to get this print value? So if I again go back to our code, right, how am I able to see this value 10 or this value 20 right here, right? So for that, if we actually move to the next one, what it uses is something called a completion record. Okay, so this record is a internal data type. This is not any this is not like an array that you can create in JavaScript. This is something which is only defined in the specification. Now there is like a new proposal for something called records, which will be available in JavaScript, but this is not the same thing, right? This is an internal data type, and what it basically says is that this is, you can think of it like a object really. It has these keys and it can have these values, right? So the main thing that it will have is a type. So when you write 2 plus 3, it will say that my type is normal, because I'm not using any of those keywords like return or something. So my type is normal and my value is 5, right? So uh, that's how the normal expression like 2 plus 3 will look. But if you do something like return 2 plus 3, right, then what it will look like is that my type is return and my value will be 5, right? So whenever you use anything like an expression statement or this return, break, or throw, it actually internally returns a completion record which has these three things. So first is type. So if you don't use any keyword, it will be normal. If you use any of this, break, continue, return, or throw, then it will be one of these values. And then the value will be whatever we return along with it. So in case of return, you can return some value, so that value will be stored here. In case of throw, you will usually throw some kind of an error, so that error will be stored in the value. And in case of normal expressions, like we said 2 plus 3, uh, the completion type will be normal, right? And if you also actually remember, right, we don't normally use it, but your break and continue, they also allow you to pass a label or a target, right? So we'll look at it later. But if you have basically two nested for loops and you want to break out of the outer loop, you can basically add a label to the outer loop and pass that to break. You can select break label 1, and that will be effectively stored in this target. So what does that look like in terms of our code, right? So again, the same thing as example. So if we say 2 plus 3, it internally returns this. I have a type normal, my value is 5, right? So it will evaluate this thing, get the value, and internally return this completion record. Similarly for return statement, so if you do return 2 plus 3, this is the completion record it returns. The type is return and my value is 5. Now, what about for loops, right? Um, so can anyone, like, if you can unmute yourself also, right? Can anyone tell how a break works within a for loop? So if I have something like this, right, I can have optional label. How does a break work in case of for loop? If anyone would like to say. Okay, sure. So yeah, this question was like, if you have a for loop, right? Something like this, where it goes from I 0 to 5, and then if my I is 3, then I want to break out of that loop, right? And then we can also have like an optional label for that break statement. So yeah, if anyone would like to explain how a break works, in case of a for loop, and especially if you have a label for that.
Is it something like if statements and for statement blocks both have completion records, and the output of the break proceeds on the for completion record, something like that?
Yeah, exactly, yeah. So normally how a for loop would work is like, if it will go from I from 0 to 5, right? And when it reaches 3, if you use break, it will complete the for loop and move out of that, right? But like you said, so how did it work internally? So when you do break of label, or we can even ignore the label for now, what it will return is this completion record. Type is break, target is something. Then it will move to the outer layer, right? It will move up one by one. So then we have this block statement. So block statement effectively sees this return like completion of break. It says that, okay, I can't handle this, I don't know how to handle a break statement, so I'll just forward the same thing, right? So again, same thing happens for your if statement. So it moves up like layer by layer. So again, if sees that, okay, this is a break, I don't know how to handle a break, so I'll just return the same thing, I'll just forward the same thing. Now, finally, it reaches our for loop, right? So, for loop kind of knows how to handle a break completion record, but it really depends on how you are like. It really depends on your target, right? So, if we had used a normal break without any kind of target, right, then for would say that, okay, I know how to handle a break statement, right? So instead of returning the same thing to my parent, right, instead of continuing to forward that same break thing, I will instead return a normal completion record, right? So for would say that, okay, uh, the input I have got is something like this, is a break completion record, but I will instead return a normal completion record, right? So what this would mean is that whoever is after this for loop, they can continue as expected, right? They will not have to handle this. This is also called as a abrupt completion record. So basically, anything other than a normal completion record is called as an abrupt one. So if you have a break, right, this is also be considered as an abrupt completion record. Now, what effectively for is doing is it's sort of converting this break completion record into a normal one, right? It's handling that. But there is a bit of a gotcha, right? So we talked about target, right? You can have break and some target like level one. So how does this work, right? So the first thing that for loop will check is that, am I the target, right? So it wants to check that, okay, I got a break completion record, right? But is it for me, right? So how will it check that? So for any for loop, right, you can put a label before that. So here in case of a for loop, we have put this label one here. So when this for loop is created, it has this array of labels that is applicable for itself, right? So here the array says label one. And like, why is it an array? Because technically you can have like multiple labels for one for loop, right? So you can basically put like this, you can put like level one, level two, lot of that, for the same for loop, and all of them will be stored here, right? And now when it got this break completion record, it will check that, okay, this value that I got, is it within this set, right? Now if it is within this set, then it is for me, which means that I handle the value and basically return the normal completion. But if it is not for me, right, so for example, if there was a outer for loop with some other label, and this label is also some other label, then it would say that, okay, this means that this break is not for me, right? I am not the target. So I'll again continue forwarding that same break completion record, right? So effectively, yeah, this is what it means. It will first check that, is it me, is the target me, right? If not, then I'll basically stop my loop, I'll do all the cleanup, and then I'll forward the same thing. But if it is yes, right, if this target is me, then I'll instead return a normal completion record. So like let's actually see that in terms of code, right? How to write that. Let's see. um, right, so let's say you have a for loop and something like this, index less than 10. Simplest case, let's say we say that okay, if I, let's say, equal to 3, then I want to break out of this for loop, right? And maybe we could do like a print after this, or maybe it should be I. So if we basically run this thing, this will be expected that okay, we'll see till 0 1 2, right? Same thing is happening, because the for loop got a break at I equal to 3, then it will just continue, it will just return a normal completion record. So that means basically something like this. So if we have like 2 plus 3 here, right, just outside this for loop, that will actually execute, right? You can see that it is printing this 5. So after this for loop is over, it will continue as if nothing happened. But what about the labels thing, right? So let's have like 2 nested for loops maybe. Let's call this I2. Right. So now we have, I think, 2 for loops. Let's call this one as outer. Let's call this one as inner, right? And what we want to do is after break, we want to pass the target. So in this case, let's say my target would be, outer basically, right? So does this make sense? I have 0 to 5 and here is 0 to 5. Yeah, we can do console.log I, and here we can do the other thing, which is that we can put some statement after this thing, right? Something like this. Let's say what happens when you run this. Right. So yeah, if you look at this now, right, so what is happening is that okay, I have the inner for loop. When it reaches 3 and my I2 is, let's say, 0, it says break outer, right? So that means that okay, it will break out of this for loop, but the return value from this for loop is a break completion record, right? So it knows that okay, I cannot handle outer, so I'll keep forwarding that same completion record. What that means is that now this block, right, this for loop's body, that cannot run this statement, right? It cannot run this statement called next I2, because this part itself, this statement itself, has returned the abrupt completion, right? So it will now go to this whole outer for loop, and now my outer for loop sees that okay, my target is out, like my label set is outer, and I have the same target. So this one is for me now, so I can basically handle it, and whatever is after this for loop, that can continue as expected, right? So this is basically how basically labels work in case of break, right? And we can also see how continue works. So that will be very similar, right? So how it continue work in some scenario like this. So what continue means is that so let's say move to the simplest case first. Right. So you have a simple case that for I move from 0 to 5, and if it's I equal to 3, we say continue, right? So what will happen again is that okay, continue is an abrupt completion record, so it will keep moving up, and then it reaches this for statement, right? Now for says that okay, because it doesn't have a target, I know how to handle this continue record. And what it effectively does is that it simply moves on to the next iteration, right? So what this will mean is that for I equal to 3, it will not print this console.log I, but the for loop will still go to the next iteration and it will still print 4 and 5. So basically, if we run this, um, yeah, only the 3 statements should be missing, because for loop basically said that okay, I know how to handle a continue completion record, and what I'll do is I'll not stop myself, but I will simply move on to the next iteration. So yeah, that is how continue and break works. Again, same thing, you can have label for a continue. So yeah, we can skip that for now. So that is the thing. Hmm. Now, like one question for again all the people, right? So what will this do? So I again have a for loop 0 to 5, and then within the for loop, I have a function like a ify, right? Where I'm trying to do that break. I'm trying to do if I equal to 3, then break, right? Will this work or not? Uh, you know, according to the explanation until now, or why does it not work? If someone wants to answer.
Uh, Sorry. Uh, is it something like the if he returns undefined actually on
Mm,
for the for block?
after this part.
Yes.
Function doesn't know. Yeah. um, hmm, yeah, I mean, I would say we actually haven't explained this mode of IHK, but yeah, function doesn't know how to handle a break. Function only knows how to handle return. Okay. Yeah. So yeah, I mean, like with our current explanation, this should actually work. Like they should actually do like a normal break, but it doesn't work because this is more or less like a, what do you say, exception that the specification puts in. So it says that like this forwarding of break or continue, right? That cannot cross a function boundary. And they basically say that okay, you know if you want to have a break, right, you have to have a outer for loop, but it cannot cross a function in between. So that is the thing. And if you also think of it, that kind of has a reason why. Because like if you have a function, right, you can call that in a lot of different places. So it will be very hard to ensure that wherever you call this function, now this is a ify, right, this will be called here. But if your function had a name and if you try to call it later on basically, so then it will be very hard to make sure that okay, outside the function I have to have a for loop, then only I can use this function, right? So yeah, that is one of the reasons why they don't allow it basically. Yeah. And also like basically if you use write this will be a syntax error. Like syntax error is more or less like a static error in terms of JavaScript. They will see that okay, if I have a break, right, do I have an outer for loop? It will like keep checking, and it will check like this, and it says, oh, I have found a function. And like I said, break cannot like cross across a function boundary. So I'll stop here and I'll say that okay, this break doesn't have a outer for loop thing, so this is not allowed basically. Yeah. And a similar thing also applies to like a label. So if I put like something here like L1 or something, some label which doesn't which is not actually available outside, so that will also give like a exception basically, a syntax error, saying that okay, what you've written that doesn't make sense. Because like JavaScript can statically analyze and see that okay, do I have a outer label called L1 or not?
Abhas, one
Okay.
question here. Can I
Yeah.
clarify this one? So what if we pass I over the this if inside if I we pass I over it here, then will it
If you
work?
do what?
If we
Can
pass
you
I,
repeat?
if we pass I,
Or if you pass
yeah,
I,
yeah,
right?
yeah,
So
yeah,
you mean like
yeah, yeah.
this maybe? Yeah,
Yes, yes, yes.
yeah. Uh, Again, that wouldn't make a difference really, because if you use a break statement within like, yeah, I mean you have to have a outer for loop, but you cannot cross a function in between. So like let's run this. Uh, yeah, it will basically say something illegal break statement.
Okay,
So
so basically it's on pass the outer. Okay, fine.
yeah, yeah, right, correct. And hmm, yeah, so this is about, let's say, for loop and break and continue. um, the other thing is, like we're saying, right, function. So how would a function work? Very similarly, so when you do return 5, right, this same thing bubbles up till it reaches the function. And now the function says that, okay, I know how to handle a return completion record, so I'll take this value 5 and I'll instead return a normal completion. So like basically when you're calling this function, not like this, but when you call this function, right, it will say that, okay, I got a return completion record with the value 5, right, but what I'll instead do is I'll return a normal completion record with the value 5, right. So it's basically acting as a handler, that if I see a return, I instead make it seem like a normal value. That's all. Okay. So that's about functions. What else can I look at? So yeah, so the next thing is try catch, right? So let's again let's say go back to our code and look at that. So if we have a try catch, let's say like this. um yeah, so we do something, throw something, uh we catch a error, right? And then let's say we do what, console log error. So how is this thing working, right? So this is also working in a similar way, that okay, this try block, right, this evaluates the body in here. Now if the body returns a throw completion record, right, so if it returns a throw completion record, then try will go ahead and evaluate this part. Basically it will run, it will assign error to this value 2, and it will run this body. But if not, right, if this thing doesn't return, this thing doesn't return a throw completion record, then try will not run this thing, and it will just continue like whatever is written below it, right. So this is like throw completion record. And also the interesting bit is that this syntaxes in JavaScript, right, they can sort of play around with these completion records, right. So what I mean is something like this, right. So this was, I think, one of the interesting questions, like more of a trick question really. But so let's say something like this. Okay, so what will this do? um yeah, so would someone like to answer, like okay, what do we do? Let's say we do like a return here maybe. Yeah, let's say the code is something like this, and maybe this is whole thing is within a function, right. So yeah, will someone like to answer that, what will this thing actually return if I call this function? Will it return 1 or will it return 2?
Just a wild guess. It will be returned to.
Return 2, yeah.
Yeah.
But what if I don't have a return here, I have just 2?
But no, no, no. I'm not running. I'm not running. I just gave a guess. I don't know why this will happen
I
every
feel,
time.
I feel like it will be two because like finally gets executed whatever like it just don't care about try. I feel like that. No, no, no. As far as I was like mentioned earlier, like
So that's an
it,
interesting thing, right? If I do console log 2, will it even print 2?
yes, 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 will get print too. I think.
that will get print 2. But what will my function return? Let's say.
I think it would be undefined. Console log 2 is undefined, right?
Mhm.
That would be the return value, I guess.
Right. Yeah. Any other guess? Anyone who would like to answer?
The return should be one. Return
Uh-huh.
should be one, but it will print control two.
Yeah. So someone is saying, right, this will print 2, but it will return 1, right? I
Yeah.
mean, yeah, that's also an interesting thing, right? Normally, like whatever we have seen till now, that never really happens, right? I mean, if you return, that will normally return right there. I mean, you cannot really control it. Uh, but this would be interesting that, okay, if I return something here, it still goes to this line, right? It still has to run this line, but somehow it sort of comes back here and like returns this value, right? And same thing, I mean, what if we do even this, right? I mean, just for example, I don't consider this as like interview questions or something, right? Or something like this. Basically, if I have a return and then I put a expression in here, right? When will my expression evaluate? Will it be like, okay, if I see a return, ignore that, move on, run this line, then come back and run this whole return line? Or will it be like, okay, if because I saw this line first, right? Sort of run this line anyway, don't actually return, right? Move on to the next line, and then if this thing doesn't return something, then return the previous thing, right? I mean, I don't know what is the easier way to explain, but something like that. So, and
Is
basically,
it
yeah, right. Basically, the second thing. I mean, it will evaluate this at the first point, but it will store this value, and because this thing doesn't do any abrupt completion, right? So it will basically sort of, you might say, replay this thing. It will return that same thing basically. So this is complicated, right? Effectively what I'm trying to say. And this is not something that we can normally do, but if we, like, for cases like this, right, we can look at the specification and see how it is defined, right? Then all these cases will become a bit more easier also. So I mean, yeah. So what I was thinking is we can look at how try catch works according to the specification basically. Oops. Try statement. Okay, let's see. So again, we basically have these forms of try statement, but what we normally look for, right, is these are static semantics, which are also not like super important most of the time. What you really want to is like scroll down till you find like runtime semantics. I hope I find it. Yeah, like this basically. Where is it? Sorry, runtime semantics. Let me actually show it. Yeah, so we have like runtime semantics and then evaluation. We are looking at this case basically. We have like a try block and then a finally block, right? So this is what it is doing if you look at it slowly. So it will evaluate the try block first, right? Doesn't matter what is the result of this b, doesn't matter if my try block did a return, throw, anything, right? It will still continue to the next line. It will evaluate my finally, right? So like Sandeep was saying, it is ensured that, okay, my try block as well as my finally block both will get evaluated, right? Now it does something interesting. Look at this. So it says that if my finally f dot type is normal, basically if my finally didn't do any abrupt completion, right? If my finally didn't do return, break, throw, whatever, right? Then set f to b. Basically, then it will set f's completion equal to whatever b returned and return that same thing, right? So it's basically saying that, okay, if f returns something, then return that thing, right? If not, then return whatever blocked returned. I mean, returns in the sense of completion records, right? So hopefully this explain some of the things like which we are seeing in our code, right? Basically, when you look at this, right, it says that okay, I'll always run this whatever is within try. I don't care what this try returns, right? I'll not even look at this at that point. I'll move on to my finally, run whatever is within my finally, right? Now I have to check what these two things are returning. If my finally returned any abrupt completion, right? Basically, if my this return type is not normal, if it is not normal, then forward this thing. But if this itself is a abrupt completion, right? So basically that means that okay, if this itself is a return statement, then forward that same return. But if this is a simple one, right, if this is not doing return or anything, then forward whatever you found in the first part, right? So yeah, this is basically what it is doing. And I mean, this also works in the same way, right? You can think of it in this way. What do you say? So what can we do? Yeah, I mean, it doesn't really matter, right? If I do a return here, and if I did like a throw here, it still wouldn't matter. Like there is no order as such that okay, if the previous one is like throw, which we think of as more important, right? So basically what I'm trying to say is this will return 1 2 3. This will not throw any error, because it doesn't matter what is like what exactly they are returning, but as long as they are abrupt completion records, this first one wins. If this doesn't do anything, then only sort of return this thing. Yeah.
Abbas, suppose I have
Yeah.
one variable inside that function, like let a is equal to 20. I'm returning that thing like return a inside the try block, and inside the finally block, I'm updating that a is equal to like 30 or 40. So if
Right.
I will be returning the
Interesting. Yeah, you mean like this, right? You want to do like this, and here you will do like
update, yeah, I'll update that
yeah,
thing.
right, right.
Will it be
Yeah,
like giving a 20 or 10? I guess 20.
nice. I mean, I would expect to give 10, but yeah, let's actually run this also. Yeah, so like this is returning 10
If
because
if that
yeah.
a is outer that try block, is it the same?
Yeah, should be, I think, like this.
Yeah, like this.
Yeah, and let's refresh this thing. Yeah, it's still the same thing.
I think if A was an object, then and like if we change one of its properties, then
That
that would affect the return value.
true. Yeah, I think that will happen.
So
Yeah.
Abhas, one thing can you try here, like make var a equal to 10 instead of making let it make it var.
This one.
Yeah. Like on line number 5, make it var equal to 10. Yeah.
Like this.
Yeah, and just remove that line number 3. Like comment that line number 3.
Okay. Yeah.
Now try that out. What happens? I think it will return 20 in this case.
Is it? I don't think so. No,
Okay.
it should return, right? Yeah.
Hmm.
I believe inside try the value is already calculated, and inside finally is not impacting the value.
Yeah.
But
Is it
but one, mhm. But where is functionally scoped? So this A is, I'm not sure how this is returning 10.
But the variable that was declared using let was also function scoped, I guess, because the let, I mean, that let declaration was written at line number 3 outside the try block, basically.
Yeah.
So I guess that object thing will work. Like if I have A as an object, and if I update one of its properties, then that would, I mean, that would get reflected.
Yeah. I think that will work. Yeah.
Now, this is crazy. Yeah.
Yeah. And and even you can add like more complicacy here, right? Basically, if you add like this thing here, I mean, you can have try, catch, and then finally, right? That is also allowed. So this now becomes even more complicated, basically. So now the logic, I mean, specification will be too hard, but yeah, now you can think of it like this. So it will run the try part. if that is a throw, like if this is a throw, if the try is returning a throw, then only it will go ahead and run the catch part, right? Now catch can also, you can understand, catch can sorry catch can also return something, right? Something 100, but it still has to go ahead and run finally, right? So if this try throws a error, then it has to run both catch and then after that finally, but then it will again do that same trick with catch and finaly's result. So it will now decide that okay, if my finally didn't return anything, I'll return the catch parts value. You get the idea, right? If my finally return something, I'll forward that and stuff like that. Yeah, I mean, let's say, yeah.
So I think like if like a is a primitive value, then like the value of a that was at line number 5 will get printed. I mean, that won't change even if like finally is trying to update a primitive value. The value won't get reflected at line number 5. I mean, the finally what is getting returned. Yeah, like I mean, if a was an object or array, I think that would have worked.
You mean like this basically, something. A dot a basically. Um, yeah, I mean, this will get updated, but yeah, I mean, yeah, this will return a20, right? Yeah, this will get updated, I think. But yeah, basically what I'm trying to say is, right, we have these completion records, right? In user land, like in JavaScript, when you're writing it, we cannot control it with so much like details, right? Basically, but a specification does a lot of these things. So basically what we saw, right? If it evaluates something, now it can decide that okay, if my evaluation was abrupt, right? Do I want to forward that, or do I want to still do some more processing, sort of before forwarding that? So yeah, stuff like that.
I think next time while using try and catch, I'll be more careful, like because now these all things are in my head. So
Yeah.
many cases. Yeah.
True. Yeah, and we can even look at more definitions. I mean, see, where is it called, right? So let's we said, right, function sort of handles return, right? Let me see if I can find that part. So this is trying to evaluate the body. Sorry, I went too many times. Uh, la. Oops, not sure. So yeah, if you actually look at this line, right, we said that function sort of handles a return, right? So this is what it does. So if you do return, let's say 5, right? So my type is return. What it'll instead do is it will give a normal completion, but it will preserve the value basically. So my return 5 effectively becomes like normal 5. So this is what function does. So yeah, I mean, this is a basic idea that you have like different types of completion records, and some of your syntaxes, they know how to handle this type of records, and they effectively convert that to a normal completion, stuff like that.
And Abhas, one more talk idea for you. Like, one talk you can take on how to read this TC39, docs. So that will be
Yeah,
great because you are, I think, very, fluently able to read all this. Like, this will be saved. This is a normal completion and all that. So I think you can
true.
always, take a talk where you can explain how to read these docs at first place.
Yeah,
That
yeah,
would be great. Yeah.
yeah. I mean, yeah, that is. Actually, I had like one session in the JavaScript meetup, I think, which was more on just reading this thing, right? But yeah, then it becomes like I mean, it depends, right? I mean, first of all, yeah, you can look into that one. But the thing is, right, if we make the whole thing about reading this doc, sometimes people feel very bored. I mean, you get the point, right? This is just textual stuff. But yeah, if you have to
Yeah.
think, if you think like what is happening, and if you want to like connect it to this thing, then it becomes like more interesting, I think.
Yeah. Yeah.
Yeah. I mean, yeah, I think that's all for the slides. I post like this random stuff on LinkedIn and some videos on YouTube. So yeah, if you want, you can watch them.
Thank you. Awesome. Thank
Thanks. Yeah. Okay. Yeah.
you.
True. True.
Not today.
Yeah, I mean, I didn't even, I haven't actually read myself the whole part about like promise and async with respect to this, right? But I think that will be interesting stuff. Like, yeah.
Well, one question I have, Abhas. So I want to ask, like, I mean, you showed us this label statement. So I saw this label statement, like 1 year or 2 year back. Then I kind of liked it. Kind of found it very powerful, but I was not able to use it anywhere. Like, what all cases where it can be, very much useful
Mhm.
and can enhance your, developer experience, or the way you write the logic, it can enhance that experience altogether. Can you just have used it at some place where you find it really great?
Right. Yeah. I mean, see, normal, I would say what do you say? Normal perception is that uh, these are very much like go to, like we had go to statement in C and stuff, right? Uh, I mean, in some way it is right because it's a control flow statement. Like
Yes,
your
yes,
code
yes,
comes from one
yes.
place to another. But
Mhm.
in my opinion, it's not that bad. Like it's sometimes useful. So like one use case I have had at least is that like I have, let's say, L1, right? Like I have nested for loops basically. Something I have like one for loop, and then I have like, I don't know, another for loop, right? So in that case, I have found it useful. Let's say you have, sorry, it looks too complicated, but anyway, let's say if you have like some algorithms, right, where you need to do like where you have a array or matrix really, right? You go to like two indexes, and then maybe let's say you are doing like a search, right? Search in a matrix. So if your thing is I and j, and if your ij is equal to whatever you are looking for, then you want to stop the for loops, right? So in that case, I find it useful to do like, break L1, so that it breaks still my outer for loop. But yeah, if you don't do that, you have to keep like a variable here that, okay, inner break equal to true, and you have to do it manually basically. That if you find the value, you have to break out of this one, and then again you have to go out and break out of the second loop. But yeah, in that case, I think break is useful.
Yeah, understood, Abbas. Thanks.
Yeah. Sure. Yeah, yeah, sure.